Okay, class. This is lab 2-3, parallel circuits. It says the purpose of this lab would be to connecting loads in parallel makes loads relatively independent of each other and allows for control of individual loads. For this reason, loads are commonly connected in parallel with each other. Okay, so the procedure: ensure that the main breaker is off, power bench is off, and the power stat is turned to 0, which I've done. Wire the parallel circuit as shown in figure 1 using the different loads that they've told us to. So here I'm using the output in my variable AC supply in terminal 4 and then my neutral coming back. So we're looking for a variable 120 volt supply. This is my line 1 coming up. This first one here will be labeled where the ammeter would have been. Okay, I haven't installed any ammeters along the way because we're going to use a clamp-on ammeter for the purpose of this lab. Okay, so if you follow it up, you see I've labeled that's a 40 watt bulb, 60 watt bulb, 100, 150, and a 200. And then below each of the terminals, I've given the black, or my line conductors, where each of those ammeter readings would be required to be input. So jumper A, or at A, is right there, B is there, C is there, D, and then lastly this would be E. Okay, so next thing that they're going to ask us to do would be to turn the power on slowly and adjust the voltage supplies to 120. So I'm going to input my meter leads. I'm in DC volts here on my meter. I'm going to input it into my source here, and I'm then going to see what voltage we get output. Oopsies, hang on. So we got 110 there. Looks like 110 is the best we got. We were doing better last week when we didn't have to worry so much about the rest of the school being operating, but the most we can get out of this one is 110. Okay, so that's the highest source voltage we're going to get. And in parallel, they're going to ask us to measure the voltages across each of these lamps. Okay, so starting at the voltage at lamp 1, it's probably kind of bright, so I'm not going to stare at the light bulbs themselves. If I were to have my meter on display there, hopefully you guys can maybe see that. It says 111.3. That's my total source voltage. Okay. Here we got 111.1 or so. It's going to fluctuate a bit. Call it 111. There's 111 there. Basically almost 111 there. And then at the 200 watt bulb, we basically got 111 there again. So it is fluctuating up and down just a teeny bit by about 0.2. So we'll just call it 111 across all of them. Okay, and then it says record the AC ammeter reading. Okay, so we're in AC amps. Okay, so what this meter does, this is a clamp-on meter. If I put the jaws of this around a wire that has current flowing through it, the ferromagnetic material in here is going to transform that current into an outputted value. Okay, so whatever current is leaving that source, which in this case happens to be 3.9 amps, I'm just going to hold that and I will show it to the camera a little bit more clearly. Okay, 3.9 amps, and then we're zeroed again there. We'll go to this one, and now we're sitting at around 3.8 to 3.9 in return. Okay, whatever leaves has to come back. Problem with these digital meters is they do a little bit of rounding, so in one case we might be seeing 3.8, the other case might be seeing 3.9, meaning it's sitting at about 3.5, or 3.85, 86, 85, 84. It's just jumping up and down a little bit there. So either way, we can call that current, to err on the safe side, we're going to call it 3.8 amps. Okay, and then we're going to go over. They're going to ask us to, I know in the lab it says turn power off and then remove an ammeter and place it into different spots. Okay, In this case, or in this circumstance, what I'm going to do is I'm going to take the readings that they ask us to take along the way here, and we can fill it out. So the ammeter at location A. So location A is the current coming in to here, taking away the value of current at this jumper that we would be leaving towards the next one. Okay? So whatever current is heading strictly into that light bulb could be found using the clamp-on meter right at the base there. Okay? And we see that 40-watt light bulb is capturing 0.2 amps. Okay? So that would be ammeter location A is 0.2 amps. Alright? Roughly 0.2 or 0.3. I'm also going to mark that down on my drawing so I can see that they make sense. Okay? Next thing, what we're going to want to do is we're going to want to know what it is at B. That would be around the base there. This is showing 0.4. So 0.4 there. This gets a little tight. Bulbs are warm, I got to be careful there. Okay. This one here around the base. The wattage is going up, so you'd expect more current there. And I give it a couple seconds to be able to analyze it appropriately. This is seeing 0.8. So jumper C is 0.8 amps. Jumper D is 0.9 amps, actually 1 amp now. And E could either be this entire wire itself or right at the terminal like I've been doing the other ones. Okay. And that says 1.3. Which makes sense because it is the biggest load. It's a 200-watt light bulb. Okay, so that's 1.3 amps. All right, so then we can look at F, G, and H. Where is F? F is, if this is E, this should be F because this is the jumper that is connecting up between loads C, D, and E. Okay, so this jumper here is jumper F. I'm going to measure him, and it is telling me it's 2.4 amps. Okay, and then what are we looking at? We're looking at this one here. This will be G. Is at 3.1 amps. And H is this one, and that's 3.6 amps. Okay. Now they don't ask us to do anything else past that point. So if we were to map the current, which I'm going to pause the video here, I'm going to turn it to the board so we can actually map the current and I can talk about it. So I'm just going to pause the video for a moment.